Hi, my name is Kiran Baburaj. Welcome to the detailed exploration of selection sort algorithm. In this presentation, we will thoroughly examine how this sorting technique works, including a step-by-step breakdown of each pass and an in-depth look at the code implementation. Selection sort is a simple yet effective algorithm that operates by iteratively selecting the minimum element from an unsorted portion of an array and placing it at the front of the sorted section. This method not only helps in understanding the sorting mechanics but also lays a groundwork for more complex algorithms. So let's consider a practical example. We have an array of numbers. Our objective is to sort this array in ascending order. Understanding how we can achieve this is crucial to mastering sorting algorithms. The strategy for selection sort is straightforward. First, identify the minimum element within the unsorted section of the array. Second, move this element to the beginning of the sorted portion. And finally, repeat the process until the entire array is sorted. Now let's analyze the performance of our algorithm. The time complexity is as follows. In all cases, it has the order of n square. While selection sort offers simplicity in implementation, its quadratic complexity may not make it most efficient choice for large datasets. Now let's illustrate the selection sort process with our sample array through detailed analysis of each pass. The algorithm starts at index 0, assuming the 64 is the minimum, and it scans the array, updating the min index to 5. That is, it finds 11 at index 5 and updating the min index, swapping the 64 and 11. Similarly, in the second pass, assuming 34 as the minimum, finds 12 at the third position index and swapping 34 and 12. And in the third pass, starting at index 2, assuming 25 is the minimum, finds 22 at the index 4 and updating the min index and swapping 25 and 22. So subsequently, through a total of 7 passes, each element was examined and sorted systematically. This selection sort algorithm effectively moved the smallest element to their appropriate positions step by step, and we got final sorted array. Alright, let's dive into the code for selection sort. We define a function selection sort with array as an input, and we find the length of array, and the main logic uses two loops. The outer loops runs from 0 to n minus 1, assuming the current index I is the minimum, setting the min index to I, and the inner loop starting at I plus 1. It finds the smallest element by updating the min index if a smaller element is encountered. So finally we swap. This exchanges the elements at index I and min index, placing the smallest element in the sorted section. So let's conclude. So it's important to reiterate the time complexity of selection sort, and in all cases it has a time complexity of order of n square. So this quadratic complexity results from the nested loops, one for iterating through the elements and another one for finding the minimum. And it has a space complexity of order of 1, indicating that it operates in place without requiring additional storage for sorting. So the selection sorting serves as an excellent foundation concept for understanding the sorting mechanisms and algorithm designs.